Welcome back to Educational Minds Hub. Today I'm going to be talking about cell to cell signaling. So as you can see, I've written cell signaling here. So there are 5 types of them. The first one is called intracrine cell signaling. The second type is called paracrine. The third one is called endocrine. Endocrine. Then we have the fourth one is autocrine, and the final one is called juxtacrine. Before I start the video, I'm just going to let you guys know I'm not going to be going over juxtacrine. You guys can look that up on your own, but in this video I'm not going to be going over that one. So let's look at the other four types of cell signaling. So for paracrine cell signaling, So let's say you have like an ordinary good old blood vessel. So let's call this blood. So let's say that there happens to be just 2 cells that happen to be there, and so 2 cells that happen to be quite close to each other, like maybe right here. That's relatively close. Let's put it right here. Like they're pretty close by. So let's say that the green cell has the receptors of the blue cell. Like cells have receptors. And maybe here's another one right here. Here's another one. Maybe here's another one. I mean, they're not supposed to be realistic. I'm just trying to show you. And then let's say this blue one has the receptors of the green cell. So maybe it looks like that. Maybe it looks like that. Maybe it looks like that. Like an arrowhead or something. Maybe one over here. So then, let's say the green one releases some of its, the blue one, so it's releasing its chemicals and stuff into the blood. So its chemicals are all in the blood. It's hormones, I should say. So let's say it happens to bind with the blue cell receptor. And note, this cell doesn't just have to have the blue cell's receptor. It could have like a whole nother different cell's receptor. It could have a whole nother cell's receptor. Yeah, it could have a whole nother one. Like that's not even related. But coming back to the point, let's say one of the hormones binds to this receptor. Since these cells were close by, this is paracrine signaling. So basically the cell will just do what the hormone triggered it to do. So in a nutshell, that's paracrine signaling. Now let's talk about endocrine signaling. Endocrine signaling, right over here. So let's say we have another blood vessel right over here. Maybe this is a much, much bigger one. Much, much, much bigger one. Blood. Oh, let me rewrite that. Blood. So, and then let's say, maybe a little more here. Actually, that's fine. So, yeah. Let's say then we have one cell that's over here. Then another cell. Oops. And then another cell that's like all the way over here. So maybe similar thing, I guess. Let's say this purple cell has receptors for this pink cell. Maybe that's the receptor, what it looks like. And then what else? Maybe it has different cell's receptor. Who knows? But yeah, let's say it also has the cell's receptor that we're looking for. And this pink cell, this is going to be the cell that releases the hormone, so it doesn't really matter for this example. But let's say it has this type of receptor, or maybe this receptor. So yeah, so the pink one, it'll do all of its dandy stuff. It'll release its stuff over the big bloodstream. Now let's say one of the hormone receptors happens to just fit in it, just snugly fit in. Just snugly fits in. Just nice and snug. So this is endocrine signaling. Because it happened over a long blood. Obviously this is to scale, but it happened over a long period of time. So finally, like in a body, this would happen in a couple of hours, and the cell would do what it's triggered to do. And that's actually how the endocrine system works. Bunch of gland the cells of a gland send the hormones out to the other cells, and that's why it takes a bit of time for that to happen. And but that also makes the effect last longer, because then it'll take time to send the stop hormone, quote stop hormone. So like example, if you I don't know, you're hiking in the woods and then you come face to face with a bear. Adrenaline, you're just pumped with adrenaline all of a sudden, and heart starts beating. You run out of there, like you run crazy. I mean, that's probably not the best way to avoid a bear, but I mean, you run out of there. You like run faster than you try to run, like run like the wind. You run like the wind, and let's say you somehow successfully manage to evade that bear. So, but your heart is still pumping due to the adrenaline. It takes some time for the stop hormone to actually calm your heart down and stuff because of this long distance signaling. So another type of cell signaling is autocrine. 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 Did I? Autocrine. think I spelled that wrong by mistake. Here, let's do that again. Autocrine. So let's say we just have one cell in this situation in our bloodstream. One cell in our bloodstream. So let me draw out the bloodstream over here. So if that's our bloodstream, maybe the cell, the hormone that it sends out, maybe it has the same exact receptor for it. So I need to really think about this. Let's say its receptor is I don't know, it looks like a square. Or it looks like this. And then the spot to fit it would be the other puzzle piece. So then let's say it has its own receptor, like it shoots out its hormones, and then it has its own receptor, and that receptor happens to fit in the, like, perfectly. It happens to fit perfectly. Like a snug puzzle piece. So it basically signaled itself and it received its own signal to do something. And finally, the last one we're going to talk about is intracrine. Intracrine. So, for this example, we're not even going to take the blood vessel into the system. Let's say we have our cell. I gotta stop using that color. I'm gonna use a different one. There. Let's use that color. So let's say this is our cell. And let's say it has a nucleus as well. I mean, obviously all cells have nucleuses. But let's take into account the nucleus. So, the nucleus also happens to have receptors, right? So let's say it has a receptor too. Or actually, it does have a receptor, like any normal nucleus would. So the cell inside is also producing hormones to regulate intercellular activity. So let's say the hormone happens to bind here. So then that'll regulate basically the intercellular activity, and it's basically talking about, or it's controlling the activity inside of the cell. So and notice that's different from autocrine because the receptor is outside of the cell in autocrine, but it's the same cell. But in intracrine, it's still the same cell, but the hormone never actually leaves the cell, unlike in the autocrine example. And then for the juxtacrine, you guys can look that up yourself. It's a bit complicated though. So, but you guys can look it up if you want an interesting scoop and story. Anyway, thanks so much for watching this video. Please subscribe to my channel, turn on notifications, and like this video. So I know that you appreciate the content, and also turn on that notification bell, so you don't miss any updates on any new videos I post. See you guys.